On a previous video, I showed a latch pin I had to fabricate to repair an antique lock. It's a fairly small part made out of stainless steel. This could be milled out on a manual mill using a mill of ice. However, this particular part had a 29-degree angled surfaces. So rather than using just a vise, I elected to use a spin indexer. This allows the part to be machined out of bar stock, and the part remains integral to the stock as it's going through the machining processes until such a point that all the machining is complete and it can just be cut off on a lathe to create the finished part. To better visualize this process, I have this animation that shows the step sequences I used for the part. This particular part fit within a 3/4 inch diameter bar stock. I used Fusion 360 to model the geometry and was able to identify the X and Y and Z positions of the milling cutter, along with the rotational position of the spin indexer and a subsequent use of a rotary table for the final operations. This particular technique is commonly used on CNC equipment, CNC lathes, CNC mills that have fourth axis. This allows you to really get a pretty accurate part without having any fixture variation. For those that do have CNC equipment available, Fusion 360 does have a module. It's not part of the base modules, but there is a module for fourth axis machining, where once you have your part modeled in Fusion, you can develop the G code automatically for the fourth axis. I've never used it myself, but anyway, this is just a good technique to use. If you've got these small parts, hard to handle, limits the amount of fixturing required. Spin indexers are fairly inexpensive, so if you've got a manual mill, you can look on eBay or Amazon for spin indexers and really help you make your workflow more efficient when you're doing these kind of small parts. For this particular part, I had to come down on the end of it with end mills, so I transferred the stock material into a rotary table to complete the machining operations. It's basically the same thing. The zero position is right in the center of the bar stock, and from that I was able to interpolate where the geometry for the mill, or where the XYZ positions need to be for the milling cutter as it was proceeding. And the final operation is to just cut it off on a lathe to get the finished part.